Hi students, in this lecture I am going to discuss previous year's IIT questions based on inductors. Let us see first one. See the question given. The inductors of two LR circuits are placed next to each other as shown in the figure. The values of the self-inductance of the inductors, resistances, and mutual inductances and applied voltages are specified in the given circuit. After both the switches are closed simultaneously, the total work done by the batteries against the induced EMF in the inductors by the time the currents reach their steady state values is. So this is what we have to calculate. Let us see how to start. So first draw the diagram given. So given here resistor, resistor and an inductor, and they are connected to one battery, and a switch is present. And you can see here EMF of the battery 5 volt. This is V1 and resistance 5 ohm. So this is a 5 volt. This is a 5 ohm and inductance 10 millihenry. 10 millihenry. That is L, right? Next, coming to this next one, resistance, and that is equal to 10 ohm. And coming to inductance, right, see carefully here. Inductance given 20 millihenry, and this is now 20 volt. Right. Now see what he's asking here. The total work done by the batteries against the induced EMF in the inductors. So we can see here now the EMF induced. Once we close the switch, current starts increasing. So because of increasing current, an EMF is induced. So we have learned that inductor opposes change in current. It does not oppose the flow of current, whereas resistance opposes flow of current. Okay, right. So first focus how much EMF is induced. So coming to here. So let me take current. So coming to current here. So take it as I1. This is I1 and this is I2. So which depends on time. So inductance, self-inductance given L1. Then EMF induced L1 into dI1 by dt. This is the EMF induced. This is what we say because of a self-induction. But we have to see there is one more coil closer to this one. Okay. Therefore, because of this means because of the change in current in second circuit, and EMF is induced in the first circuit. Okay. And that is given by, I am writing here plus or minus M into dI2 by dt. Because the current is in second circuit, because of that change in current, and EMF is induced in the first circuit. Okay. And see here why we have taken plus or minus. This mutual inductance means because of mutual induction, an EMF is induced. and that EMF may support this one. That means mutual induction may support self-induction. And that happens when both inductors having windings in the same sense. If they are in opposite sense, then it will oppose. That means if windings are in the same sense in both the inductors, mutual induction supports self-induction. Then we are going to take a plus. Otherwise, we take minus. Okay. This is now EMF induced in the first one, right? Now multiply this with the current in first one. That gives us a power developed against this EMF induced. So let me take it as P1. Now in the same way, I am writing EMF induced in second circuit L2 di2 by dt plus or minus M into, because of change in current in first circuit and EMF is induced in second circuit. That's why I have taken di1 by dt. This is EMF induced in second circuit. Multiply with the current. Then this is power developed because of the induced EMF. Okay. Now we have to calculate work done by batteries. And we are knowing that power equal to, it is a rate at which work is done. From that, dW, that is equal to P into dt. Okay. Then see what I can write here. dW, that is equal to, or I can say integration of that is equal to, if I multiply with dt. So here P means P1 plus P2, sum of those two. See what happens if you multiply with dt. This becomes L1 di1 plus or minus M into di2 into I1. Right? So I'm writing that here. L1 I1 di1. See carefully. L1 I1 di1 plus, coming to here, L2 I2 di2, because into dt, right? L2 I2 into di2. See next what is left. M into I1 into di2 plus M into Y2 into di1. I am writing here plus or minus, see what I can write here. I1 into di2 plus I2 into di1 into M. Okay. Now take limits. It is from 0 to 0 to, see what we get. He is asking until steady state is reached. Therefore, first one becomes half L1 I1 square. Okay. I1 square plus half L2 I2 square. I hope you are getting this point. L1 di1, integration of that, L1 square by 2. Same thing, L2 square by 2, right? Next, coming to here, plus or minus. Now see carefully. I am writing this part. That means, just see carefully this part. I1 di2, I2 di1. See how I am writing that? I am writing that as d of I1 I2, because that is equal to I1 into di2 plus I2 into di1, right? So in the place of that, I can write d of I1 I2. Then integration of d of I1 I2, that becomes I1 I2. So this becomes now plus or minus M into I1 I2. So I hope you got this calculation right. Now coming to limits, we have to take up to steady state values are reached. And you can see here peak current 5 by 5. It is E by R 5 by 5. So I1 maximum value, it is 1 amp, right? I2 maximum value 20 by 10, that is a 2 amp. Okay. Now substitute those values in this. Then see what we are going to get. So this work done stores in the form of magnetic potential energy, right? Then see what we are going to get. It is equal to a half. What is L1? L1 is 10 milli, right? So 10 milli, 10 power minus 3. I1 square, it is 1 square plus a half L2 value 20 millihenry. Current is now peak value how much? 2 ampere. It is now 2 square plus or minus M value. See M value I have not mentioned here. See diagram once. It is given 5 millihenry. Coefficient of mutual induction, that is given 5 millihenry. Substitute that here. 5 milli 10 power minus 3. I1, I2, 1 into 2, that is 2. Let's see calculations. 2 here 5 times. So 5 10 power minus 3. Here 10 times. This is 10 into 4, 40. 40 plus or minus, see how much it is now. 5 into 2, that is a 10, right? So let me cross check once. This is a 5, this is a 40, and this is how much? 10. Plus or minus 10. This is a millijoule because we have 10 power minus 3, 10 power minus 3, 10 power minus 3. That is millijoule. So if you take now, this is a 45, 45 plus 10, 55. 55 millijoule. If you are taking minus, it is 35 millijoule. Okay. But if you see practically, our intention is to store more potential energy. That means if it is a supporting, means if you take a plus, in that case, it will be 55 millijoule. Otherwise, it can be either 55 or 35. Okay. Let us see next one. Right. See the question given. In the figure below, the switches S1 and S2 are closed simultaneously at time t equal to 0, and a current starts to flow in the circuit. Both the batteries have the same magnitude of the electromotive force and the polarities are as indicated in the figure. Ignore mutual inductance between the inductors. The current I in the middle wire reaches its maximum magnitude at time t equal to tau. Which of the following statements are true? Okay. It's asked in 2018 advance. Let us see how to start. So first of all, focus. First, see the circuit diagram given. Resistance given R and inductor, that is L, connected to a battery through a switch. It is through a switch, and having here one more resistor and inductor. resistance R, inductance 2L, and connected through a switch. So it is now right. And given both batteries having same EMF, okay, now see what he's asking here. In the middle wire, current is given as I. Okay, that is, and he's asking the maximum value of I. I maximum how much? Okay, and this happens at time t equal to tau, and that value how much? This is what we have to calculate, right? Now see how we are starting this. If you focus only this loop, the left part, okay, then see what will be the current. So I'm taking that as I1. So taking as I1. So I1 equal, and that current will be like this, clockwise. I1 equal to, once we close the switch, current starts increasing. So it is now growth of current. In that case, it is given by peak value V by R into 1 minus e power minus R by L into T, right? Next, if we consider only right part, okay, then current will be V by R into 1 minus e power minus R by 2L into T, okay. And if you observe in the middle wire, because of this left one direction same, but because of right one direction opposite, that means I equal to, it is I1 minus I2. Okay. See what we get. V by R gets cancelled. Remaining is now V by R into, I have taken I1 minus I2. That means it is e power minus R by 2L into T minus e power minus R by L into T. Right? So now we got current as a function of time. So to get maximum value, now we have to differentiate this and we have to make it equal to 0. Okay. Let us see what happens if you differentiate this. Differentiate this and make it equal to 0. Di by dt equal to 0. That implies. So anyhow, V by R is not a 0. It is non-zero value. So remaining, I am focusing here. Then see what we get. Derivative minus R by 2L, right? E power minus R by 2L into T minus of minus plus R by L e power minus R by L into, this is equal to G, right? Now simplify this. So if you simplify this, we are going to get e power minus R by 2L into T, that is equal to half. Okay, it is e power minus R by 2L into T, that is equal to half. Right. So from this, see what we can write. So you can take now, if I'm reversing this, it becomes a 2, it becomes a plus, then take antilog on both sides. Then we are going to get T equal to 2L by R ln 2. Okay. Next, if we are using this one here in this place, take 1 by 2. And this becomes 1 by 4, right? Because it's now square of this one, right? So 1 by 2 minus 1 by 4, it is 1 by 4. That means that corresponding maximum current, that is equal to V by 4R. Okay. So it is simply focusing circuit separately, then we have to superimpose, right? And man just calculation part. Now see the next problem. So coming to your correct options, it is B, V by 4R, and D, 2L by R ln 2, right? Okay, see the next question. Consider an LC circuit with inductance 0.1 Henry and capacitance 10 power minus 3 farad kept on a plane. The area of the circuit is 1 meter square. It is placed in a constant magnetic field of strength B naught, which is perpendicular to the plane of the circuit. At time t equal to 0, the magnetic field strength starts increasing linearly as B naught plus beta t, and given beta value, the maximum magnitude of the current in the circuit is. Okay, let us see now how to start it. So first focus here. The key point given, that is B is changing now linear, right? So since magnetic field is changing in this area, flux changes. So since flux changing, an EMF is induced. Okay, right. So first of all, okay, write down the given data. Inductance 0.1 Henry. Next, capacitance C equal to 10 power minus 3 farad, and area of that loop given 1 meter square, and B value is given as B naught plus beta t, where beta equal to 0.04 Tesla per second. Right. Now what I am saying is, in this loop, flux is increasing because B value increasing, right? So I'm calculate now how much EMF is induced. That is equal to minus d5 by dt. I'm just focusing what is modulus value. That's why I'm not taking minus here. So d5 by dt, area, it is 1 into dB by dt. That becomes beta. That means 4 10 power 1 to 10 power minus 2 volt. This is the EMF produced, which is a constant, which is constant. Now focus how circuit is. One inductor, next capacitor. This is connected to one battery. Now question is like this. Okay. Initially capacitor uncharged, no current in circuit. Now switch is closed. And for this battery, EMF is now 4 10 power minus 2 volt. This is now question. Okay. Means instead of giving inductor capacitor, there is series combination with a battery. We are given battery's EMF indirectly. Okay. Right. Now coming to calculation part. See what we are doing here. Right. Now coming to here, I'm taking between these 2 points potential difference. That is equal to battery's EMF. Right. So now what I'm writing here, that battery's EMF is equal to when current flows, means when switch is closed, when current flows like this. Since the current is increasing, it tries to oppose that change. Therefore, I replace this one with a battery like this. This is a plus, this is minus. And coming to capacitor, this becomes a plus and this becomes minus. Now writing here Kirchhoff's second law, then say what we get. So plus 2 minus L di by dt. Next, minus q by c. Next, plus E equal to 0. Right. Now see how we are writing this equation. This equation we are writing as now. In the place of 5, I can write dq by dt. Okay. So here I equal to how much? I is dq by dt. It is the rate at which charge on capacitor is increasing. Okay. Right. Now see what happens here. Or I can multiply here both sides with minus. So it becomes now plus. So L d square q by dt square plus q by c minus e equal to 0. Now I am rearranging this one. See how to write this one. D square q by dt square plus 1 by LC into q minus EC, that is equal to 0. Am I correct? Check it once. Q by LC, Q by LC, EC by LC, that means E by L, right? Now this equation can be written as d square by dt square of Q minus EC, because EC is a constant. So even if you take derivative once or twice, there is no change, means that becomes 0. So this is equal to this value. Okay. See the advantage of writing in that form. Now we can say this quantity is changing simple harmonically, right? So this I can compare with what we call, suppose I'm calling this as x, then d square x by dt square plus omega square x equal to 0. It is of that form. That's why I have taken like this. Now from this I am writing q minus EC, that is equal to what? I am writing maximum charges as q naught sine omega t. And see why I am taking here sine function. Because when switch closed, if I am taking that as t equal to 0, at that instant capacitor was uncharged. Okay. So q minus EC equal to q naught sine omega t. Right? Otherwise, I think let me correct once. Because if I'm taking Q is a charge on capacitor, then what happens is, wait, let me write, just to cross check once what we have written here. We are saying Q is now charge on the capacitor. In such a case, when I'm taking T0, this becomes 0, but this is not 0. That means a Q equal to EC, right? And that is wrong, because after a long time, capacitor will be fully charged. Okay, that means here see what I have to write. I am writing it to avoid confusion. It is a plus 5, some constant. That is what we have to calculate. Okay, now Q equal to EC plus Q naught sine omega t plus 5. Okay, This is giving us a Q as a function means charge on capacitor as a function of time. So in this, we have to calculate now what is a Q naught and what is a phi. Okay. And to calculate these two, now see what we can do. At t equal to 0, Q equal to 0, right? That implies Q0 and next what else? So Q0, T0. Therefore, what else left here? It is a phi. So sine phi. And I can say Q naught sine phi. Q naught sine phi is equal to minus EC, right? This is one condition. Next condition, when we close the switch when time t equal to 0, at that time current is 0. Current is 0 means dq by dt is 0. Now differentiate this. If we differentiate this, what we get? Current equal to Q naught omega, see this carefully, Q naught omega cos omega t plus phi. Okay. Now in this t equal to 0, I equal to 0. Okay. So t0, I0. That means what else left here? Anyhow, this is not 0. T0 remaining is cos phi. Cos phi is equal to 0. That means the phi value how much? Phi value, it is 9. Is it okay? Phi value how much? It is 9. So once the phi value is known, see what he is asking here. See the question once what he is asking. So coming to the question, he is asking the maximum magnitude of the current. Maximum magnitude. So here, if I differentiate, in fact, even this calculation for us not required. Means what is a phi? Okay, even that also not required because this is current and this value is maximum if this cost function is maximum. So directly I can write here I maximum is equal to Q naught omega, right? And what is a Q naught? If you want to know Q naught, then we require calculation of this, right? This is a phi value because if phi is known, then we get the value of Q naught. See number of unknowns. One is Q naught and one is a phi. This is one condition we got and we got now phi value how much? 90. Phi value how much we got? 90. So when I'm taking phi 90, Q naught, it is minus AC. And when we want maximum current, focus modulus value. Therefore, I'm writing here EC. Okay, it is AC into omega. Omega means how much? Already we got the value of omega. This is what? This is omega square. Because this is of the form d square x by dt square plus omega square ax equal to 0. So omega value is now 1 by root LC. Right? Now see what we get here. Answer is now E root of C by L. Right? Now see what is the value of C? 10 power minus 3 and L value 0.1. 10 power minus 3 and this is now 10 power minus 1 and E value we got 4 10 power minus 2. Right? That means see finally the value comes out to be, let me cross check, 4 10 power minus 2. This is okay. 10 power minus 3, 10 power minus 1. Remind 10 power minus 2, 10 power minus 2 under root, 10 power minus 1. Already having here 4 10 power minus 2. So this becomes 4 milliampere. That is maximum current. Okay. So I hope you got a clarity.